So I've said that exceptions are objects, and just like all other objects in Java, that means they are part of a hierarchy or an inheritance tree. So the exception class hierarchy is designed to include all classes that define exceptions. So these are all of our classes that we use to represent erroneous situations, and they are all related through inheritance, forming a hierarchy, and they're all descendant from the class called throwable. So all of our error and exception classes, for example, all the ones we've been using that Java generates, are all inherited from throwable. So this is our exception class hierarchy. The top is throwable. Of course, throwable inherits from object. So up here would be the object class. Okay. And inheriting from throwable are two main classes, exception and error. We've been talking about exceptions, but there is also another inherited class from throwable called error, which I'll talk about in a moment. From exception, there are kind of two types of classes that inherit from exception, and one is a set of runtime exceptions. These are what's called unchecked, and then there is a set of checked exceptions. So we basically have kind of uh, three types of exceptions that we can write, and then well, three types of erroneous situation objects, I should say. One would be unchecked runtime exceptions, one would be checked exceptions, and one would be errors. Okay, so these are kind of the three types that we might see. Errors, they're kind of like exceptions because they represent erroneous situations, but they're different because they're serious problems from which your program can't recover, and you are not expected to deal with these in your code. So errors usually happen from external conditions like something going wrong inside your computer or something like that. They're basically really unexpected and serious problems that you are not expected to handle. So anything that happens kind of down on this side of the tree, you basically do not have to account for in your code. This is stuff that if it happens and your code crashes, your program crashes, it should crash. You aren't expected to handle it. Now, we do have objects that are of this type so that when your program does crash, you get some information about what went wrong because these objects still contain that information, but you aren't expected to handle that. This stuff, checked and unchecked though, this is what we really want to think about when we think about exception handling. And all of the exceptions that we've looked at today in this video have been of the unchecked variety. Okay, so exceptions come in these two types, checked and unchecked. And exceptions we do want to account for in our code. Unlike errors we're not expected to handle, exceptions we should. But there's a really critical difference between checked and unchecked exceptions. Checked exceptions have to be dealt with. So the compiler ensures that we handle checked exceptions. If we don't deal with checked exceptions, we will not be able to compile our code. Unchecked exceptions don't have to be explicitly handled, meaning the compiler isn't going to enforce that we handle them, but we probably still should handle them. Okay? So it's good practice to deal with both checked and unchecked exceptions in your code. So from a good programming standpoint, I want to account for both of these kinds of situations, checked exceptions and unchecked. But the difference is the compiler will force me to deal with checked exceptions, whereas an unchecked exception, the compiler doesn't care if I deal with it or not. Your teacher cares if you deal with it or not, but the compiler doesn't. Okay, so let's just look again for a second at our code entry program. So before I wrote, remember my very first, the very first time we ran this program, it did not have any of the exception handling in it, right? It just looked like this. Just had my normal execution flow code, no dealing with the erroneous situations that might come up. And guess what? My program compiled and it ran just fine. And when I put in a bad user input, the program crashed. But it compiled just fine and it ran just fine. That's because number format exception and string index out of bound exceptions are unchecked, meaning the compiler does not enforce that I have to handle them. I can, but if I don't, compiler doesn't care. it's bad design not to handle them, right? Because if I now run this code and the user puts in bad input, my code crashes, and I don't want that. So I should handle them, but the compiler does not enforce it. Okay, and that's the key distinction there with checked and unchecked. All of these unchecked exceptions, I do not have to handle them from a compiling standpoint, right? Here my code compiles just fine. Okay, I am going to handle them because I don't want my code to be terrible, right? So I am going to handle them, but the compiler doesn't enforce it. Now, with a checked exception, the compiler does enforce it. Okay, so in a checked exception, I have to handle my code. And if I don't, I will not be able to compile. Okay, by handle a code, that means one of two things has to happen. I have to either catch it right where I am, okay, I have to catch the exception, or I have to propagate it. Now, there's one difference in propagating. The examples we looked at, we're propagating unchecked exception. The one difference with propagating a checked exception is that if I'm going to do that, if that's how I decide to handle my exception by passing it to the previous method, I have to actually tell the compiler somehow that I've done that. And how I do that is with what's called a throws clause inside my method header. We'll look at what this means in a minute. Now, don't get confused about the difference between throw and throws. Those are both different reserved words in Java. This is throws with an S, and it goes inside the method header. And basically, this is just the way of telling the compiler, yes, I recognize I have a checked exception. I've decided I am not going to catch it, so I do not have a try-catch block, but instead, I'm going to pass it to the previous method, and I'm indicating that with my throws clause. Okay, so if I have a checked exception, I have to do one of these two things. Basically, it takes off that third option of ignoring it. Remember, with an unchecked exception, we said we could ignore it, we could handle it where it happens, or we could propagate it to the previous method. With a checked exception, we don't have the option of ignoring it, so we have to either catch it or propagate it up a level. And if we decide to propagate it up a level, we have to tell Java that by including a throws clause. Okay? So if we don't do one of these two things, then we'll get a compiler error. Checked exceptions represent conditions that our program should anticipate and recover from. So these are basically exception situations that we know are likely to happen and that we need to anticipate. A classic example of this is a non-existent file. So if we have a program that's doing file input and file output, if that file doesn't exist, our program's not going to be able to run. And so we need to handle that through exception handling. And because that's such a kind of situation that we should be able to anticipate, Java makes that kind of exception checked, which means it's telling us you can't use this code to file input, file output unless you handle this error situation. It forces us to do it. Okay, again, unchecked exceptions do not require explicit handling. Okay, so we don't have to have a try-catch block. We don't have to have a throws clause. We can have a try-catch block and we can propagate exceptions up to the previous method, but we don't have to because they're unchecked. Okay, they're runtime exceptions. So examples of this are our array goes out of bounds, our string is out of bounds, index is out of bounds, we divide by 0. All of these are unchecked exceptions, right? We haven't always been writing try-catch blocks every time we use an array. That would be kind of silly. That's an unchecked exception. We aren't forced to deal with it. A lot of times unchecked exceptions happen from logical errors. So for example, trying to divide by 0 or trying to access an array index that's out of bounds, those are errors in your code. So a lot of times with unchecked exceptions, you can just avoid them being generated at all by being careful about the way you write your code. Okay. Now, sometimes you might want to take advantage and use unchecked exceptions like we did in code entry, right? We took advantage of the fact that, hey, I can use these unchecked exceptions to make my code work the way I want to. So sometimes it's good to use unchecked exception handling. It can be a benefit to you. But in a lot of cases, you can just avoid having to use it by being careful about how you write your code and just avoid generating those errors. Okay. An array out of bounds index should really never be caught, and you never want that to be the reason your program crashes either. That's like a really bad error to see because it just is kind of an indication of sloppy programming. Okay, so we're going to look at an example of checked exceptions, in particular using input and output.